Okay, so as you guys know, I told you all on Monday that we will have a test on Friday. Um, the test on Friday, it will be your third 6 weeks test. The reason why I'm giving the test on Friday, in other words, I'm giving it in the middle of the 6 weeks, is because when we get back from winter break, we're going to start preparing for the final exam that sums up the entire semester. So I'm going to go ahead and get the 6 weeks test out of the way. And guys, the 6 weeks test is really not that bad. The 6 weeks test is only 15 multiple choice questions, and it covers three topics: universal gravitation, energy, and working power. Okay, we're going to talk about working power today. I'm going to give you the equations for that. Okay. Um, if you're just now coming in, go ahead and get the attendance form filled out. Okay, so just keep it in mind, guys. Our 6 weeks test will be this Friday, and you're going to take the test before you head out for your winter break. The test is only going to it's just 15 multiple choice questions. Okay, and you're going to take the test uh, in Eduphoria. So I'll be sure to have the instructions up for you guys this Friday, just like you did last time when you guys took your test in Eduphoria. Okay, so just keep it in mind. Okay, let me go ahead and share my screen so we can go over the important thing we're going to be talking about today. So, if I go to Schoology, okay, first period, okay, okay. Today is December the 16th, and it is a Wednesday. Okay, so I'm going to click on that. Okay. So, as I said today, we're going to be talking about work and power. I'm going to go over the work PowerPoint first, give you guys the equation for work, and then we're going to work out a few examples. And then we're going to go over the power PowerPoint after that, work out a few examples, give you guys the equation for power. And of course, for your assignment for later on, as soon as we're done going over everything, I'm going to make the assignment available to you guys, which is just 10 multiple choice questions. And obviously, you're going to need a calculator because mainly today we're just going to be focusing on using the equations for both work and power. Okay, because there will be work and power questions on the exam this Friday. Okay, so that's what we're going to be discussing. Okay. Before we get to that PowerPoint, real briefly, let me review what we talked about last time. So last time we talked about the conservation of energy, and we said that the total amount of energy in the universe is conserved. Okay. We also talked about the conservation of energy in a system. So, for example, here, imagine here that I have a single system. Okay, and the and this system is my skateboarder. Okay, guys, assuming we are ignoring friction, right, to take this energy out of the skateboard and put it in something else. If we're ignoring friction, the basic idea is that the energy of this system stays conserved, meaning that kinetic energy just keeps going back and forward to potential energy, and so on. So kinetic energy becomes potential energy, back into kinetic energy again and again. So the basic idea here is that I want you guys to see that whenever the guy's at his highest point, he has his greatest potential energy. Okay? And then, he speeds up. Okay, and at his lowest point, he has his greatest kinetic energy. Okay? The basic idea here is that if you know the potential energy at the top, you know the kinetic energy at the bottom. And I say that because there's going to be a few questions on the test that go over this concept with you guys. That the conservation of energy. So let me write this down here. So the guy's potential energy at the top. So um, potential energy at the top will be equal to the kinetic energy at the bottom. And again, the assumption is that we are ignoring friction here. We are ignoring friction, which slows the system down and takes energy and converts it into thermal energy. So we're ignoring friction. So the potential energy at the top is equal to the kinetic energy at the bottom. Okay. So, for instance, guys, imagine that. So, the skateboarder is at the top of this hill here. Okay. And let us imagine that he has at the very top, right on my screen here. Imagine that at the very top here, he has 5 joules of potential energy. Oh, I don't want to write that big. So imagine that he has 5 joules of potential energy at the very top here. Okay. So why is at the very top? He has all potential energy, but then gravity starts acting on him and brings him down. And so as he goes to the bottom, he picks up speed, therefore picking up kinetic energy, the energy of motion. So guys, if his potential energy was 5 joules here, that means his kinetic energy here had to be 5 joules. So the kinetic energy at the bottom there we go. Okay. So the kinetic energy at the bottom had to be 5 joules. Okay. That's because his potential energy at the top is 5 joules. Now, what is his kinetic energy at the very top? Well, that's easy, guys, because look, as he goes all the way up, notice he comes to a stop before he comes back down. So if he comes to the stop at the top, that means his kinetic energy at the top is 0 joules. Okay, right, because he comes to a stop, and then by the time he goes downward, okay, again, all of that potential energy became kinetic energy. So if he lost his potential energy, that means at the very bottom, his potential energy must be 0 joules. Okay. So hopefully everyone got the basic point here. The basic point is that all of this potential energy at the very top was converted to kinetic energy at the bottom. Okay. And we see that here with the bar chart or the bar graph. We can clearly see that relationship. One gets converted to the other. Full potential energy at the top becomes full kinetic energy at the bottom. Okay? And that just keeps transferring like that continuously because the energy of the system is conserved. We're assuming that there's no friction taking energy out of the system and putting that energy somewhere else. Okay. One more thing I want to say here, guys, and this is very important that you guys know this for the test. Guys, at this halfway point right here, okay, this is the only point right here on the system where, this is the only point where the system's potential energy is equal to the system's kinetic energy, right? And we see that here. Notice he has so notice at this halfway point right here. So if his potential energy, hold on guys, let me write on this. If his potential energy is 2.5 joules at this point, that means his kinetic energy would be 2.5 joules at that point, right? So at this point right here, the energies are half and half. Basically, for the test, you guys know that at the halfway point is the only point where the system's potential energy is equal to the system's kinetic energy, right? So, here the potential energy was 5 joules, and as he went down halfway to the point, he lost potential energy, right? Because it went from 5 joules to 2.5 joules, but he gained kinetic energy. And here at the halfway point here, both the energies are equal. So, that's the only point where the system's potential energy is equal to the system's kinetic energy. So that's something that you guys need to know for the test. Okay. And one more thing I want to say, guys, for the test, whenever you are making your calculations here, remember this basic rule: the potential energy at the top is equal to the kinetic energy at the bottom. Because there are going to be some questions where, like, there are going to be some questions on the test where they may say, they may give you all the information to calculate the potential energy at the top, but they may ask you what is the kinetic energy, in other words, kinetic energy at the bottom. If they do that, guys, what you would do, you would just use your equation for potential energy. And if you use your equation for potential energy, then you immediately know what the object's kinetic energy is. Okay, and of course, vice versa, they could give you another problem where they give you all the information to calculate kinetic energy, and they ask you, well, what is the object's potential energy at the very top? Well, in that case, you will calculate kinetic energy at the bottom, and you know whatever that is equal to your potential energy at the top. So there's just something to keep in mind, because you guys will have equations. I mean, you guys will have questions like that on the test. So it's important that you guys know how to use your equations. Remember, the equations for potential, the equations for gravitational potential energy is, go ahead and write this down. So the equation for gravitational potential energy is mass times 9.8 times the object's height. The equation for kinetic energy is 1/2 times mass times the velocity of the object squared. Okay. So those two equations will be important on your test. Okay. All right, guys. Let me move on from this and talk about work and power. We're going to start with the work power point first. Work and power is really easy. Basically, all you have to do is just know how to use the equations. So this is the PowerPoint that I have uploaded into Schoology right now. The first PowerPoint is called Work. So work is how forces add or subtract energy from an object. In fact, another definition that you will see for energy is the ability to do work. So energy and work are two concepts that are related to one another in physics. You know work is being done on an object if the object's energy changes. Okay. Work occurs when a force moves an object over a certain distance. Okay. So that brings us to our equation for work. I'm going to write this down because you guys will need to know this for the test. The equation for work is equal to force times distance. It's a very simple equation. The equation for work is equal to force times distance. So that's something you guys need to know for the test. So work occurs when a force moves an object over a certain distance. Okay. If the force and the distance are acting in the same direction, we will say positive work is being done. If the force and the distance are acting in opposite directions, we will say negative work is being done. Okay. Basically, positive work puts energy into a system, and negative work takes energy out of a system. In other words, positive work gives an object energy, negative work takes energy away from an object. Okay. So, guys, I'm going to say this on your tests, and also whenever you're working out your homework problems, please be sure that you're looking at your units and that you're getting your units correct. So we know work is equal to force times distance. Guys, the unit for work is joules. Guys, the same unit that we use for energy is also the same unit that we use for work. So joules is what we use for work. Remember, there's this relationship between work and energy. Force we know is in newtons, and distance we typically say is in meters. So keep this in mind whenever you're working on your problems. Okay. With that said, let us do a few example problems, because these are going to be like the example problems that you're going to see later on. Okay. How much work is required to push with 300 newtons of force a box 10 meters across the floor? Okay, so this is easy. Remember what I said, work. So for number one, we know work is equal to force times distance. So Notice we push with 300 newtons of force. Always look at your units. 300 newtons of force. Okay. And we're pushing 10 meters across the floor, so that's our distance. Okay. So in this case, work is 300 times 10. Okay. And what is 300 times 10? 300 times 10 is 3,000 joules. Okay. So that's how you calculate work. Super easy. Okay. Force times distance. So let's look at number 2. If a person does 200 joules of work to slide a box 2 meters across the floor, how much force was acting on the box? Okay. So let's write our equation here. Go number 2. So work is equal to force times distance. Okay. So it says that the person does 200 joules of work. So that's our work being done. So I'm going to plug in 200 joules here. Okay. And we know that the box slides a total of 2 meters. So that's our distance. Our distance is 2 meters. Okay, so I'm going to plug in 2 into this equation. And we want to know how much force was acting on the box. So in other words, we need to solve this equation for force. Guys, y'all know how to solve this equation here, how to get F by itself. We need to do the opposite of multiplication. We need to divide by 2. That goes away. Whatever we do one side, we have to do the other. So that means force is equal to 200 divided by 2, which means my force is 100 newtons. Okay. Guys, please be sure you always get your units right because that'll be important on the homework assignment and on the test. Okay. So that's how you do number 2. Okay. All right, well, let's go to a few more examples. Okay. If a person does 300 joules of work with a force of 150 newtons, how far do they move the object? Okay. So number 3, if a let me see, do I have enough room? Number 3. Let me just open up a new page. Okay, number 3. Okay, so a person does 300 joules of work with a force of 150 newtons. How far do they move the object here? So in this case right here, we're asked to solve for distance. So work is equal to force times distance. Okay, so the force, well, the work done here is 300 joules. Okay. The force is 150 newtons. So now the goal here is to solve this equation for distance. How far has it traveled? So we need to do the opposite of multiplication. We need to divide by 150. That goes away. Whatever we do to one side, we have to do to the other. Okay. So 300 divided by 150, that gives us a distance of 2 meters. Okay. So that's our answer for number 3. The object goes a total distance of 2 meters. Okay. All right, so let's do the last example here on the work PowerPoint before we move on to power. Okay. A man weighs 800 newtons. He climbs a ladder and travels 3 meters upward. How much work did the man do to get to the top? Okay, so this is interesting. Okay, so guys, the man's weight is 800 newtons. So guys, imagine a man is climbing a ladder. Okay, and he has a weight of 800 newtons. Okay. So guys, if you're climbing a ladder, here's the basic idea here. As you're climbing a ladder, you are doing work against gravity to go to the top. So that means your body, has to push off against the force of gravity. So that means the force of gravity is what goes into this equation here to solve for work. Well, but what is the force of gravity? Remember what we said weeks ago is that the force of gravity acting on an object is always equal to the weight of the object. Okay, so we said that before. The force of the force of gravity is equal to an object's weight. Okay? Force of gravity is equal to an object's weight. So with that said, guys, if we want to calculate the work done, by the man as he's climbing the ladder, remember, work is force times distance. Okay. But what is the force that we're talking about here? We're talking about the force of gravity because he's acting against gravity to get to the top. So that means the work done by the man to get to the top is just equal to his weight times the total distance that he's traveled. Okay. Well, what is his weight? It says his weight is 800 newtons. So 800 newtons. Okay, and notice we see that he traveled a total of 3 meters upward. So 3 is the distance. So 800 times 3 gives me 2,400 joules of work. So the man, as he climbed this ladder, okay, he did 2,400 joules of work to get to the top of the ladder, to climb a total distance of 3 meters. Okay, so he climbed a total distance of 3 meters. Okay. Any questions on work before I close today talking about power? Okay. Any questions on work? Okay. And guys, this PowerPoint is uploaded into Schoology in case you guys want to go back and look over it. Okay. Now, the last thing we're going to talk about today is power. So this PowerPoint here, we're just going to go over a few things, and it just has 3 questions. So we're just going to close the day talking about power and completing these last 3 questions. Okay. Now, what is power? Okay, power by definition is how quickly work is being done. Okay, so how quickly you do work is called power. So again, power refers to how quickly work is being done. If an object works quicker, it uses more power. So in other words, a machine that works quicker than another machine is said to be more powerful than another machine. When I say it works quicker, we mean that it works it does the same amount of work in less time when compared to another object or compared to another machine. Okay, so that brings us to our definition for power. Okay, power. I'm gonna write this down because this is an equation you guys are gonna be using on the test. Power is equal to work done divided by time. So time is important whenever you're talking about power. Power just refers to how quickly work is being done. So work divided by time is equivalent to power. That's what we mean in physics when we talk about power. How quickly you're doing the work. In other words, work divided by time. So this will be an important equation that you guys will need to know for your test and also for your assignment later on today. Okay, so now let's just go over a few units. Okay, so as I said, power is equal to work divided by time. Guys, in physics, the unit for power that we use is the watt. So power is expressed in watts. Okay. We already know that work is expressed in joules. Okay, because we use the same unit for work as we do energy. And the unit for time is seconds. Okay. Now, guys, since power is equal to work divided by time, and we know work is force times distance, sometimes you will see the power equation written like this. The power equation is equal to force times distance divided by time. Okay. So let us do a few examples. Okay. Joan did 2 joules of work in 5 seconds. How much power did she use? Okay, so let me start a new blank page. Okay, so for number 1, okay, power is equal to work divided by time. Okay. So if Joan did 2 joules of work, so she did 2 joules of work. Okay. And we see that she did it in 5 seconds. So 2 divided by 5 is equal to 0.4 watts. Okay. So that is our unit for power, watts. Okay. So Joan used 0.4 watts of power, and because she did 2 joules of work in 5 seconds. Okay. Let us keep going. Let us look at number 2. Number 2, a 450 Newton person ran up a flight of stairs with his book, which was 10 meters high. If it took 30 seconds, what was the person's power? Okay. So remember, power is work divided by time. Power is work divided by time. Okay, so a 400 Newton person, so that means, yeah, if that's his weight, well, I'm sorry, no, that's not his weight. That's his, yeah, that is his weight. That's his weight, and we're also given how high that he went. So that means, guys, we can actually use our equation for work here to calculate the work being done, as this guy went up the flight of stairs. So work, remember, work is force times distance. So that means in order to figure out this person's power, we need to do force times distance divided by time. In other words, we need to figure out his weight, because he's acting against the force of gravity, his weight times distance divided by time, and that'll tell us the power as he went up the flight of stairs. Okay, so let's do the math here. So his weight was 400 newtons. So that means he did work against the force of gravity. So we're going to plug in 450 newtons for force. The distance is 10 meters. So the distance is 10 meters. Okay. And it took a total of 30 seconds to reach the top. Okay. So guys, when you do the math here, 450 times 10, okay, that's 4,500. Divide that by 30, gives me 150 watts for my power. So number 2, 150 watts is power. Okay. Okay, last example we're going to do today. This example here says how much work is being done. How much work is done using a 45-watt light bulb for 2 hours? Okay. Before we do this problem, first thing I want you guys to know is that 2 hours is equivalent to 7,200 seconds. Okay, so you have to convert hours to seconds first before you do your math here. So, okay, so let us get ready to work this. Okay. So number 3 here on this PowerPoint. Okay, how much work is being done using a 45-watt light bulb for 2 hours? Okay, so remember, guys, power is equal to work divided by time. Okay, so 45 watts. That is the power that we're given. So 45 watts. Okay, and of course we want to solve this equation for work. Okay. And we're told that it took 2 hours to use the light bulb. Well, we're told that the light bulb was on for 2 hours, meaning it was on for 7,200 seconds. So I'm going to plug in 7,200 seconds into my equation here for time. Okay. Now, the last thing that you guys want to do here is that you want to solve this equation for time. I'm sorry, you want to solve this equation for work, because that's what it's being asked here. It says how much work is being done by this light bulb. So guys, in order to solve this equation for work, we need to do the opposite of division, which means we need to do multiplication. So I'm going to multiply this by 7,200. Okay. So I do that, that goes away. Remember, whatever you do to one side of the equation, you have to do to the other. So I'm going to multiply the left-hand side by 7,200. So 7,200 times 45 is equal to my work done. Okay. What is 7,200 times 45? Well, that is equal to 324,000 joules of work being done by that light bulb. Okay. And that is our final answer for number 3 here on this PowerPoint. Okay, any questions on what we did today? Okay, so just so you guys know, these PowerPoints are uploaded into Schoology with the equations, and of course this video will be posted on my YouTube page, so that if you guys want to go back and look and see how I did several of those examples, you're free to do that later on. In just a moment, give me about 10 or 15 minutes, and I'm going to have the work in PowerPoint, the work in Power assignment available for you guys. It's multiple choice questions. Basically, you're just using your equations to solve for work, power, or whatever it asks you to solve. Any questions before I let you guys go? Okay, so if there's no questions, don't forget to get your assignment done this afternoon. And also remember, there will be a test on Friday. The test will cover universal gravitation, energy, work, and power. And again, all those PowerPoints are, they're still available in Schoology. The video from universal gravitation is still on my YouTube page. So if you guys need to go back and review that stuff, you still have access to that information. Okay, if there are no questions for me, you guys are free to go. Does anyone need for me to put the attendance form in the chat box for you all? Okay, I just put the attendance form in the chat box for those of you guys that need it.